Welcome to Gear Up for Mocks. Today we will learn about complex numbers. So complex numbers came into picture when the mathematicians, they were working on some problems and they found that they are encountering some numbers like root of -4, which is practically not possible. So what they did was they introduced some number called I, which is called the imaginary number. So that what they will do is instead of -4, they write it as -4 times -1. That can be written as root of 4 times root of -1, and root of -1 is nothing but I. So I is the imaginary number. So then this one will become root of 2i. Okay. Similarly, if you have root of 100, it will become 10i. So I is the imaginary number. And whenever we say about a complex number is it'll consist of two parts, which is like real part and an imaginary part. So, and the complex numbers are always denoted by set. So for example, if I have set as a complex number, I can say it as 3 plus 4i, and 3 is the real part and 4i is the imaginary part. Okay. And also any real number, like for example, z is equal to 4 is a real number. Okay. Any real number can be considered as a complex number with a 0 imaginary part. Okay. It's also denoted by C. The complex number is denoted by C. Now, um, for this complex number, if you say I, and if you are calculating I square is equal to I times I, which is equal to square root of -1, square root of -1 times square root of -1, that is equal to 1, -1. Okay, so I square is equal to -1. Similarly, if you find I cube, if you simplify that, you will get that as -I. Okay, and if you find I to the power of 4, you will get it as 1. Okay, so let me just write it properly. I or I to the power of 1 is equal to I square is equal to -1, I cube is equal to I to the power of 4 is equal to 1. Okay, now this pattern will repeat. Like for example, if you say I to the power of 5, that is again equal to I to the power of 6 is equal to -1, I to the power of 7 is equal to I to the power of 8 is equal to 1. And this pattern will repeat as and when four numbers get added. So what we say is, if to simplify any power of I, like for example, I to the power of 25 or something like that, what you do is you divide the power by 4, and then if the remainder is 0, I to the power of I to the power of that particular number will be 1. Okay, will be equal to I to the power of 0, which is 1. If the remainder is 1, it will be I to the power of 1, which will be equal to I. The remainder is 0. If I to the power of 2, that will be equal to -I. And 3, I to the power of, it will be equal to I to the power of 3, which is equal to this will be -1. I to the power of 2 will be -1, -1, and I to the power of 3 will be -I. Okay, so that's the concept which you can apply. So if you want to find out something called I to the power of 12, what you do is you divide 12 by 3, which is equal to 4, and 12 divided by 4, which is equal to 3. 12 divided by 4, which is equal to 3. So no remainder. So no remainder means this will be the case. So that is you can say it is minus. Um, no, it can say it as it is 1. Okay, not -1, it is 1. This is equal to 1. Okay, and I to the power of, for example, 59 over 4, you will get a remainder of 4. So if that is the case, I to the power of 59 will be -I. Okay, now you have a concept of Argand diagram. Argand diagram is nothing but we are trying to represent the complex number in a coordinate plane. So in this case, what you have is that the x-axis will be denoting the real number, which is this one, and this one will be the y-axis will be denoting the imaginary number. So in this case, if you are taking like a unit circle sort of thing, -1, and here also -1, so this is 1. So what will be the real, the complex number? Here it is I, and this will be I square, this will be I cube, this will be I to the power of 4, again this will be I to the power of 5, this will be I to the power of 6, I to the power of 7, and then I to the power of 8, and it goes on like that. Okay. Then there is a concept of modulus of a complex number. So what happens is when you are representing a complex number in an Argand diagram, so as I said, this is real number and this is an imaginary number, and if this is the complex number, z is equal to a plus bi. So what I can say is this side is called a and this end it is b. So in that case, uh, what you can say is you can take this as a right angle triangle. So the modulus of z, okay, is equal to square root of a square plus b square. So this is called the modulus. So you can work it out from using the trigonometric constructs which we have this value. So for example, if you have a set which is 4 plus 3i, and if you need to find the modulus, what you do is like you it's square root of 4 square plus 3 square, that is equal to square root of 16 plus 9, which is equal to square root of 25, that is equal to 5. Okay. Now second thing what you have to learn is addition or subtraction of complex numbers, addition and subtraction. So when you are adding or subtracting two complex numbers, you add the real parts to the real parts and add the imaginary parts to the imaginary parts. For example, if you have z1 is equal to square root of 3 minus I and z2 is equal to 2 root 3 plus 5i, z1 plus z2 is equal to, so add the real parts together, which is like root 3 plus 2 root 3, then add the imaginary parts together, so it is like minus I plus 5i, so that is equal to 3 root 3 plus 4i. Okay, that's the same with subtraction also. When it comes to multiplication, if you are multiplying a complex number with 2 plus 3i with just a constant value, it is same like algebraic multiplication. So what you can do is like 3 times 2, 6, 6 plus 9i. It's directly simple as that. Okay. And now if you are multiplying two complex numbers, like for example, if z1 equal to 2 minus I and z2 equal to 3 minus 2i, and if I want to find z1 z2, you have to multiply these two complex numbers, so it is like 2 minus I and 3 minus 2i, then you multiply just like algebraic terms, so it is nothing but 2 times 3 minus 2i minus I times 3 minus 2i, that's equal to 3 times 2 is 6, 6 minus 2 into 2 4, 4i minus 3i plus 2i square, that's equal to 6 minus 7i, I square is minus 1, so that is this will become minus 2, and that is equal to 4 minus 7i. So remember, whenever you are multiplying the complex numbers, you multiply it just like algebraic terms, but you remember I square is equal to minus 1, so you just sub in for that value and then you will get it. Okay. The next concept is conjugate of a complex number. Conjugate is nothing but it's a symmetric or reflection across the x-axis. So for example, if you have a complex number called 3 plus 2i, the conjugate will be 3 minus 2i. Okay. And if you have a number called 1 minus 1 plus I, the conjugate will be minus 1 minus I. Another one, 0 plus 4i, it will be minus 4i. Okay. Now division, if you are dividing two numbers, like for example, if you have z is equal to 2 minus 3i and z1 equal to 2 minus 3i and z2 equal to 1 plus 2i. If you want to find out z1 over z2, let me write this out first. 2 minus 3i divided by 1 plus 2i. In this case, what you do is you take the denominator and multiply with the conjugate of multiply the numerator and the denominator with the conjugate. So the conjugate of the denominator is 1 minus 2i. So you multiply the denominator and multiply the numerator with the same conjugate. So it is like 1 minus 2i, and then you multiply it together. So the numerator will become 2 into 1 minus 2i minus 3i into 1 minus 2i divided by the denominator will take the form a plus b a minus b, that will be a square minus b square. So then you can simplify this as 1 plus 4. So this one will be 1 plus 4 because I square is equal to minus 1, and that will be 5. So I can just directly write 5 here. Okay, and this will be 2 minus 4i, 2 minus 4i, okay, minus 3i plus 3 into 2, 6i square. So that will be 2 minus 7i minus 6. So it is like minus 4 minus 7i over 5. Okay, sorry, here everywhere there is 5 in the denominator, and you will get this value. Okay, so whenever you need to divide, you multiply the numerator and the denominator by the conjugate of the values. Now the last thing what you have to learn is I'm sorry. Yeah, conjugate, okay, finding the roots of a quadratic equation. Like for example, uh, it's called complex equations. For example, if you have to solve an equation called z square plus z plus 1 is equal to 0, then what you do is like you can just directly use the minus b formula here. So in this case, a is equal to 1, b is equal to 1, and c is equal to 1. So z will be equal to minus 1 plus or minus square root of 1 minus 4 times 1 times 1 over 2 times 1. Okay, then that is equal to minus 1 plus or minus root of 1 minus 4 over 2. That is equal to minus 1 plus or minus root of minus 3 over 2, and we know that root of minus 3 is equal to minus 1 plus or minus 3i over 2. So the roots here are minus 1 plus 3i over 2 or minus 1 minus 3i over 2. So these are two roots, and one will be the conjugate of the other. Now we have to learn conjugate root theorem. That's called conjugate root theorem, which means that if you have a equation f of z equal to 0, the same like what we showed in the previous equation, and if z1 is a root of this equation, then the conjugate of z1 will also be the root of the equation. For example, so in this case we saw that, okay, there's one complex number which is a root, and we saw that the conjugate is also a root. So that's what the conjugate root theorem says. If z1 is the root, conjugate of z1 conjugate will also be a root of the equation. So that will also come into direct, you can directly write this. Okay, so now you can have questions like z, or is like complex number is equal to complex number equation is equal to z cube minus 1. The question can be like, find real root of f of z. Okay, and the second part can be find complex roots. So to work the first part, find the real root, what you can do is like z cube minus 1 is equal to 0, or you can write that z cube z cube is equal to 1, and z equal to cube root of 1, which is equal to 1. So z is equal to 1 is a real root of this one. Okay, if z equal to 1 is the root, z minus 1 is a factor. Okay, this is a common algebraic thing. Z minus 1 is a factor, and from that, how we will find out the other two roots? You just divide it. Okay, so what you have to do is like z cube minus 1 divided by z minus 1. How will you divide this? You use long division, z cube minus, or you have to write all the terms. So z cube minus 0 z square plus 0 z minus 1 divided by z minus 1. Okay. Now here what you do is use a long division, just like our algebraic long division. So it is like z cube minus z square, and then the sign will change, so this will get cancelled. So z square plus z square is 2 z square. No, sorry, it's 0 0, so it's like z square, then you will bring this down, so 0z, then plus z, so which is like z square minus z, and then you will change the sign, so again it is z minus 1, then plus 1, which is z minus 1, 0. So then what you will get is x square plus z plus 1 is a factor, and there's no remainder, and this you will solve it again by you will solve this again using the same method of minus b formula, and then you will get the values. This is the same as the previous one, so I'm just going to write it directly. So it is like minus 1 plus or minus square root of 3I over 2. Okay, and the last thing what you have to learn here is yeah, sorry, one more thing, polar form of the complex number. Okay, so polar form of the complex number means a normal form of the complex number is x plus yi. Okay, x plus yi. Now if you have a complex number like this, and if you are trying to represent it in an Argand diagram, so it is like x plus yi. Okay, now we know how to find the modulus of this. The modulus of this number is equal to square root of x square plus y square. Now there's one more concept. If this is making an angle of theta with the x-axis, you can say that this is x and this is y, and then you can specify that tan sine x is equal to sine theta is equal to y over r, or y can be written as r sine theta. Okay, also you can say that cos theta is equal to x over r, or x can be written as r cos theta. So now z is equal to x plus yi, that can be written as r cos theta plus I r sine theta. So that also you can write it r times cos theta plus I sine theta. This is called the polar form of a complex number. Okay. So what you do is, so this is called the polar form. So how you do an example? If you have an complex number called 1 plus I. Okay, so we will just try to simply plot it. So you will get that it is in the 1 plus I is in the first quadrant. So first you find the modulus. So the modulus is square root of 1 plus 1, which is equal to square root of 2. And then you have to find the theta. Theta is the angle which it makes with the x-axis. So in this case, what you do is you find tan theta. Tan theta is equal to y over x. Okay, y over x. So that is equal to 1 over 1, and theta is equal to tan inverse 1, that is equal to 45 degree, or pi over 2 radians. Sorry, pi over 4 radians. So in that case, the polar form can be written as z is equal to r is square root of 2 cos pi over 4 plus I sine pi over 4. Okay, now let's take the case of another example, which is like minus 1 plus square root of 3i. So when you plot this in the Argand diagram, you can see that it is in the second quadrant. So it is minus 1 plus square root of 3i. Okay, this is the complex number. So now the angle is this one. This is the angle which you have to consider. But if you consider the right angle triangle, the right angle triangle will be like this. This is root 3 and this is 1. So the angle what we are trying to find is going to be this one. Suppose if I call this alpha. Okay, alpha is the angle which I will be calling. So here also you first find the modulus. So this is set. The modulus will be equal to square root of minus 1 square plus square root of 3 square, that is equal to square root of 4, that is equal to 2. Okay, now you need to find out theta. So instead of finding the theta will be 180 minus alpha. So to find alpha, you can write tan alpha is equal to square root of 3 minus 1. So alpha is equal to tan inverse square root of 3 minus 1. That will be equal to 60 degree. Okay, so then that is alpha. So theta will be equal to 180 minus 60, that will be 120 degree, and in radians it will be 2 pi over 3. So then you can write the complex number in the polar form um, with the formula before. Okay, now just wanted to show you a couple more things with respect to representing the complex number on an diagram. So if you have z is equal to 4, how will you draw this in the coordinate plane? So if you have z equal to 4, 1, 2, 3, 4. So this is nothing but 4 plus 0i. This doesn't have a imaginary part. So what you will do is like in the complex number is represented by this one, this line. Okay, and suppose if you have the complex number z is equal to 2i, okay, then what will happen? It will be represented on the imaginary axis. So this is 1 and this is 2, and the complex number will be represented like this. Okay, and suppose if you have anything other than that, if you have the real part and the complex part, you have to find the modulus, and you have to find the angle, then represent it into the coordinate axis. Okay, the final part of this complex numbers is De Moivre's theorem. Okay, this is in page 20 of the formula book, so you can refer that. The De Moivre's theorem talks that like if z equal to r cos theta plus I sin theta, okay, if z is this, then z to the power of n can be written as r cos theta plus I sin theta to the power of n, which can also be written as r to the power of n cos n theta plus I sin n theta. Okay, so this is De Moivre's theorem. Okay, now I have some videos which explains the De Moivre's theorem and also the applications. So the applications of De Moivre's theorem are it's to raise the okay, let me just write it down, is to raise the complex number to the power of a specific number to a power. Like for example, it can be set to the power of 5 or something like that. They will ask you the question like this. Second is to find the roots of complex number. The third is to prove trigonometric identities. So I have a playlist with detailed videos on all these three. So if you are interested, please go through that and try to understand De Moivre's theorem. This complex numbers, there is a sure question. There will be one question out of the complex numbers. So if you are able to understand this topic and able to handle that topic, it will be a very good add-on to your mock exam. So please try to study this.